All right, welcome to the second video in the series where we're going to be going through our build of a system that we're going to use to create custom crown forms for hat making. And in the last video, we walked through all of the steps to scan a vintage form and then clean up that scan and turn it into a mesh. In this video, we're going to be taking that mesh and then further cleaning it up in a CAD program, Rhino, rhinoceros, sometimes called Rhino. We're going to clean it up in Rhino and then turn it into an export that we can then 3D print. All right, so I'll include a link on where you can purchase this software. And I'm also going to include a default template model. And in this case, we're just going to hit New Model. And it's going to automatically bring up our template. And this template is designed specifically for this project to do crown forms. I've also set up layers here. I'm probably going to hide this panel, but I want to show you here. I've set up layers that basically describe in order what it is we're going to do. The X, Y, X, Z, Y, Z would be 2D CAD models or DXFs that you would import if you were going to do, in a separate video I'll talk about this, but we reverse engineer a brim form from scratch, and we do that by importing 2D profiles. We don't need those three for here, but we're going to be starting with importing the raw mesh. Then we're going to do a quad remesh. We're going to orient that in 3D space so that it gets to the right position. We're also going to scale it when we do that, but then we'll also do a 1D scale that gets us to a true oval. And then we're going to trim the base. I mentioned this in the last video where we need to basically trim the bottom with a clean plane so it's flat. And then we're going to add the holes. These holes here, this is a better example. These holes here we're going to subtract that from our model, and this gives us the standardized holes that would be used in a typical crown. And so it'll fit with your existing system. Okay, one thing we're going to want to do with these layers, we want to turn off stuff that we're not looking at right now. So we'll right click on this and say one layer on. So now that this becomes the active layer, but we've hidden everything else. All right, so we want to import the raw mesh. So if you go up to the command bar in the top left corner, we'll type in import and navigate to the file that we exported before. So whatever you named it, I named it this. I named it square.1ply. And we will open that. The units are going to be millimeters. We import. When the part's active, it'll be yellow. As soon as I click off of it, it's no longer yellow. And I can sort of like navigate around here just to see that it is what we expect it to be, which is correct. Now, and you notice that it came in at an odd angle just based on where the scanner started. And so eventually we're going to orient this into to the correct origin and orientation. But first we're going to start with, we do a quad remesh. So select that again, and you're going to go to Mesh Tools. Let's see. quad remesh. If you look at that up in the top right command line, quad remesh, it's going to pop up a window. We're going to set our active, the quad count to 1,000. That adaptive size is fine. We'll say detect hard edges, yes, and then convert to sub D. The sub D part is what allows it to be interpreted as a solid. Now, we're not going to check these things here. These would make the model more accurate to the scan, but that's actually not what we want here. We don't want to capture all of the imperfections in the texture on the surface. If this were a different project, you may want to include these to make the model more accurate to the scan. In our situation, we actually just want to capture the main curvature, but keep the texture as smooth as possible. So we're not going to check these boxes. This is all you want to check here, and I've got this set to 1,000. All right, so let's apply that. Here's the progress bar up in the upper left-hand corner. All right, and here's the result. Okay, and while I'm here, and this is selected, I'm going to move this to our quad remesh layer. And that was hidden, but now let's turn that layer on and the other one off, and this is what we've got. Okay, so that looks pretty good. At this point, you could do a test to see what this is going to look like how smooth it is going to be by exporting this as an STL and then taking a look at it, and just do a check to see if that looks like it has the right amount of smoothness to it. And we could also turn this on. Let's see. Turn this layer on, and you can, if you wanted to, you could just sort of compare it to the previous mesh. You can see like this, it's approximating some of this stuff here. You can see like a little bit of a difference between the quad remesh and the actual mesh, the scan. So there's some minor like offsets and differences, but it looks pretty good. It looks pretty close. All right. And it's okay that we're missing some of that, because what we actually want is we want something that's really smooth, that captures the primary shape, which is what we've done here. Okay, so what I've done here is I've opened our original mesh in Mesh Lab, and I also exported our quad remesh as an STL so that we can get a comparison of the two. And so this is the STL, and you can see we have a nice smooth surface here, which will be good for use as a crown form. It has the right amount of smoothness. And when we turn on our original, they look pretty close. And the reason that they overlap here is because they were in the exact same orientation. The other thing we can do here is we can make this one a mesh and keep the other one as a solid. And so now we're actually looking at both of them, and so it looks like these are both meshes. So it looks like they're fairly close tolerance here. This is the quad remesh just as a set of polygons. All right. So this looks pretty good. And that's what we want. We want something that's nice and smooth and doesn't have a lot of texture, and something that we want our final crown form to look like. All right, that's just a little check, and we're going to get back to the cleaning it up in Rhino. All right, we're going to orient our quad remesh, and we're going to start by creating a line that will be used to translate that to our x-axis. And so the first thing we want to do is look at this mesh and try to figure out where that line would be to create the x-axis. We want it to be on the bottom down here, but lined up from back to front. And so first we want to do is we want to basically use our mouse to orient the mesh so that we're looking at it directly from the back. It doesn't matter if it's pointed up or down, as long as we're looking at it straight from the back. And you can kind of do that by comparing the different ridges, the different ridge profiles. But it looks like that this is about the middle. Doesn't need to be exactly perfect because we can tweak it in the end. So we go to our command line, type in line, and then we'll pick a point on our mesh. I'm going to move this out of the way temporarily. Pick a point on our mesh, and we can see the point in all three views, so we know where it is. And so we want to be approximately at the back and the bottom. That's the starting point of our line. And then for the end point of our line, we want to be in the front mesh. And again, look at all three views to make sure we've got that, and then click. And now we have a line going from back to front. And again, it doesn't have to be exactly perfect because we can do a minor tweak to that. All right, now we want to create an orthogonal line that's going to be on our y-axis. So again, we come up to the command, type in line. And this time we're going to pick the midpoint of our line, and then we're going to come out, and we're looking for something that's going to be orthogonal to this. And you may have to move it around a little bit to make sure that we're orthogonal. Okay. All right, it's not on the y-axis, but it is orthogonal to our x-axis, so that's going to be close enough for this step. It wouldn't give us an exact tangent because it doesn't know what tangent is in this case for the y-axis. All right, now we're going to orient this to our XY plane, and so we'll go to the command again, and we'll type in orient 3-point. Select the objects to orient. We're going to orient all three of these, both lines and the model. Hit enter. Select the first reference point, which is going to be the center, the midpoint of the line we drew, or the end of the second line. The next one is going to be the front. And so we have to find where that front is, which is that one. And the third one is going to be the end of the other line. Which is here. And then for our target point, we're going to say 0, 0, 0, origin. The second point is the x-axis, so we'll do 1, 0, 0. And the third one is going to be the y-axis, so 0, 1, 0, click. All right, so now we want to rotate around the y-axis to get us where we're supposed to be. So we want to go into make sure we're on the ZY plane, which is this one that says right. I want to make sure that this is highlighted. And we're going to say rotate. Select the objects to rotate, it's that one. Hit enter. Center of rotation, we're going to say 0, 0, 0, which is the origin. And then we're going to type in an angle, and it looks like we want to be about 135. Let's see. Oh, not quite. That got us close. Now we want to be another 90. So let's do that again. And say 90. Oop, nope. Okay, in that time we had top highlighted. We don't want that. We want to make sure that this one was highlighted. Okay, select our object, center of rotation. Oops. Nope. Okay, make sure that right is highlighted. And our object selected. We'll type in rotate. Rotate. Center of rotation is 0, 0, 0. And our angle is 90. Okay. All right, we're getting closer. Looks like we maybe need another 10 degrees. So we'll do that again. And say 10. Nope. Looks like we need to be more like 5. Go -5. Okay. Right now we're really close, but not quite. So we're gonna do the same thing, but we're gonna rotate by 1 degree increments until we get there. So we'll do -1. Okay, I think that has us really close, and the way that we can tell is when we're looking at the very tip, we're about 2 millimeters off of this line here for that edge, and 2 millimeters off this line for that edge. Now obviously this is not in the center, but I think it means that we need to rotate this to get it back to the center. All right, so this is part of the orientation process. We've rotated it on the ZY plane. Now we're going to rotate it on the XY plane. Okay, so now we want to do the rotation on the XY because we can see that this is a little bit off because the crown tip is right here. And we want it moved up, so about maybe another 5 degrees. So in this case, we want to make sure that this top panel is highlighted because that's where the rotation is going to happen. And then we'll click that, type in rotate. Again, the center is going to be our origin, and then we'll say 5 degrees. It's hard to say for sure, but this looks like we're really close. And we can look at it from all three angles. To me, it looks like it needs to go like maybe another degree. So again, while this is active, the top view active, and we've selected it, we're going to rotate again. 0.000, and then we're going to say 1 degree. Okay. That looks better to me because that looks like we're right in the center now. And even this one looks like we're much closer to the center. I think this needs to be shifted down slightly because this looks like it's off to this side and this looks like it's up. All right, so now we're going to do a move. Instead of rotate, we're going to do a move. And it looks like we need to drop it at least 1 millimeter. Let's try dropping it 1 millimeter. We'll say move. Again, our top window is active here. Move from the origin to -1 millimeter on the y-axis. Okay, it also looks like this is tilted, the front's tilted slightly up than from the back over here. So we're going to rotate this down maybe 1 degree from front to back. And so we want to be on the front view. And again, we'll say rotate. Our center is going to be the origin again. And then we're going to say -1. Okay, and that gets us closer here to here. All right, I think that's good for rotation. And then the last step is we can see that the front and the back are both below the origin line, but from the right hand view, it looks like that we're above this by about maybe 5 millimeters. So I think we're going to want to chop that at 4 or 5 millimeters, which means we want to move this down. So let's say we're in the right view here, and we'll move from the origin to 0, -4, 0. Okay, so now we can see in our front view, we're well below, from front to back, we're well below that cutoff line. And from our right hand view, it looks like we have like a little bit of curvature there, but we'll still be cutting it cleanly across. So we're going to go with that. Okay, so we finished our orientation. I should have moved this to the orient layer. So what I'm going to do is I'm going to make a copy of this and paste it, and then put that on the orient layer. And then when I turn this one layer on, I get this. If I go back to this one, what I should have done is I should have kept this as the quad remesh of this thing. So to show you the steps the way it would have been in order is I'm going to delete this, and then this should have been the quad remesh here. Same settings. And the reason I want to keep this in separate layers is that in case I need to go back and adjust anything, I will have all of the layers, and this should be on the quad remesh layer. I'm going to put this on the quad remesh layer. Okay. So in this way, I could go back to each step. If I need to go backwards, I can start over from previous step. Okay. Unfortunately, we did it out of order. But if we go back to this one, now we're at the orient layer, orient 3D, and then now we want to do the scale scaling portion. So we're gonna copy this, make a copy, paste, move that to the scale layer, and then set this to be on. All right, that way when we scale this, we'll still have our original version of the quad remesh. Okay, now we're on our scale step here, and the first thing we want to do is want to scale, do a 3D scale first. Now this crown, we measured it physically. It's 22 1/4. Our target is 23 1/2. All of our other crowns, we need all the crowns to be normalized to the same size, and we're using 23 1/2 as that size. So that scale factor, that's basically 1.056 scaled up. So we select this, go to our command line, scale. Again, our base point is going to be the origin, and our scale factor 1.056. This will take us from a 22 1/4 size to a 23 1/2, and you just notice that it popped up bigger. Okay. Now we can do a comparison. If we go back to our layers, we'll turn on the XY layer, and this XY layer has an oval of what it should be, and it's this one, not this outer one, but the one to the inside. So it looks like our shape is not quite correct. All right, so we're going to do a 1D adjustment of that oval also. Okay, it looks like the main thing is that we're not centered front to back. So what we're going to do is we're going to look at how far off we are here. Looks like 1/2 millimeter. And over here we're off by 2 millimeters. So we want to move it backwards about 1 1/8, or sorry, 1 1/4 millimeter. So 1.25 millimeter. All right. So we're going to move that backwards. We want to be minus 1.2500. All right, so that got us centered. Okay, so we notice that our form is actually not on what would be considered a pure oval, which is fine, but we need to move it. We need to scale it to get to that pure oval. The first thing though is that it's also, we notice it's not quite centered, because we have about 3 millimeters between the mesh and the line we're trying to hit on the bottom, and then we have actually more like 4 millimeters from here to the line we're trying to hit. So the first thing I was going to do is we're going to move this up about 1/2 millimeter to get it centered. Starting point's the origin, and then we're going to move up 1/2 millimeter, 5, 0. Okay, that gets us, that gets us centered. Okay, now we're going to use our 1D scale to scale the mesh, but just in one dimension. Want to pick the mesh as close to that line as possible, and then we want to move it to there. All right, and notice that it did it on both the top and the bottom. All right, so we scaled it. We're off by maybe 1/4 millimeter on that side. That side looks good. Okay, this is off by about 1 millimeter. 1 millimeter. But we also have some space here. So I think we're going to be okay here because it's off a little bit there, but it's also off a little bit here. And the thing to keep in mind is that this gap here is where our felt is going to go. And so if anything, it looks like this might need to move back up just a hair to give us more room. Anyway, but it can't be perfect, so I think this is going to be close enough for right now. And we're going to go with that. All right, the next step after the scale went deep, we're going to trim base. So again, I want to save my current model. So what I'm going to do is I'm going to copy it and then paste it, and then move the pasted version down to the new layer. And this is so that I can keep a version of every step that I go through. And then we're going to make this our working layer and turn all the other layers off. And you notice that when I do that, the trim base, in my default template file, I have a plane already set up, and that plane is going to be what we use to trim the base. And basically it's going to be a Boolean split is what we're doing. So we select, let's go to the command, do Boolean split first. Let's see, Boolean split. We select the surface to split, which is our mesh, and hit enter. Then we select the cutting surface, which is the plane, and then hit enter. And then now what we have when we select, we have two different objects. You can see here it's asking if do we want to select the sub-D or the poly surface. And in this case, because this is the trimmed layer, we're going to select the poly surface and then delete that because we don't need it anymore. And then for the top one, this top piece, we want to select, it's going to ask us again, do we want the sub-D or the poly surface? We want to keep the poly surface and delete the sub-D. All right, so now our model is just the quad mesh that's been split. And you can't even see that the base here is flat. There are no polygons in the base, it's just completely flat, but it is still a solid. All right, so that's the trimming part. That's actually one of the easier steps. All right, now we're going to go to adding our tooling holes. Okay, again, to add our tooling holes, what I'm going to do is I'm going to, again, make a copy of this and then put it onto our tooling hole layer, and then make that the active layer. Again, in theory, you don't need to do this, except that I'm trying to make sure I conserve a copy of every step in case I need to go backwards. All right, and now you can see what I showed you in the beginning is that we have some solids that represent the holes that we want to subtract from our mesh. And in this case, instead of a Boolean split, we're going to do a Boolean difference. And so you just go to the command line, type Boolean, and you look for Boolean difference here. Select what we want to subtract from, which is our quad mesh, and hit enter. And then what we want to subtract with, and we're going to select there's 4 of these shapes here. 1, 2, 3, 4. And then hit enter. Now it gave us, again, now we have 2 poly surfaces. One before, one is before the Boolean difference, and one is after. So we're going to get rid of the one we did before. All right, now you may have noticed up here when we did the Boolean difference, let's just go through this again. It has the option to delete the input. So you could have done that. You could have deleted the input. That would have made it automatic, or you can delete it manually. That's just an option. I prefer to delete it manually so that I know what I'm getting. All right. So now we have a fully fledged crown form model, and at this point we can export that and then 3D print it. Okay, now we want to export this. We can select and we go to our command, export. And we want to select STL. There's a bunch of options here for different file formats. We want STL. We don't need textures. We'll go with the default options, and we're just going to choose a name. Let's say 1B. 1A was my test export earlier. I'm going to call it 1B. Export is going to give you options for tolerance. That's fine. Apply. All right. And this export options, you can export as ASCII or binary. It's important for our future tool that we do it in ASCII, which means that it's human readable. It's also computer readable. So we want, when we do our next step where we're blending meshes, we're going to want it to be in a file format that's easier for our Python script to read. So we want it in ASCII. All right, then export that. And then I'm going to open that up in MeshLab just so we can take a look at it. Okay, so we've opened up, we have our original form here. We've opened up in MeshLab. And I also opened up our finished model. And you notice that it's oriented to the origin and X and Y. And we can turn this around a little bit. And we can see on the bottom, it has our tooling holes that work with our standard setup. We can also look at the mesh itself. These are all the polygons, and you can see the polygons on the inside there. All right, so that's what we want. Looks good. Got all the tooling that we needed in there. And now, if we wanted to, we could 3D print this. In fact, I probably will walk you through how to 3D print this. Okay, we're going to print the crown that we just created in Rhino, and that we exported in STL. So right now we're in this is the Bamboo Lab X1 Carbon. This is the prep software for that 3D printer. So the first thing we're going to do is we're going to import the STL, and we essentially find it in where we exported it. So square 1B is my export, and we just open that up, and it looks the way it should. You'll notice that it already oriented it with this flat. If that didn't happen when you're doing yours, you would use one of these functions up here to like lay on face and select the face. First thing we're going to do is we're going to select the material. I have a PLA, like a wood, simulated wood PLA. It's still plastic, it's not wood, but it looks like wood. The quality we're going to use is standard, but we are going to use supports, and I like the tree supports for this, and I can show you why. If we slice the plate, okay, once we have it oriented the way we want, we slice it. That's the next step. And once it's sliced, I will show you what the support looks like. Get rid of that. Okay, we can go by layer and see what we've got. Here you can see the cells, the inner support structure, which is fine. This is plenty enough strong for making hats. Okay, here's the nice thing about this type of support is that it's very sparse at the bottom, which makes it easier to break out, and then you can see that it gets to solid at the top. Okay, so these little trees make it a lot easier to pull out of, to clean out of your part than if it were the standard type of support. All right, so that's why I like the trees for this particular one. All right, that's our, yeah, we can see it from the bottom here too. That's what it's gonna look like. Okay, so this is ready to print. So we'll go to print plate. This is just your printer settings here, the PLA selection, and then we'll just hit send. This looks like it's gonna be an 11-hour print, almost 12-hour print. So you should anticipate that. And this is a really fast 3D printer, so anticipate it's gonna take a long time. All right, now it's in the printing phase. It's just doing a warm up, but I'll finish it here, and then we'll see what maybe halfway through I'll give you a little preview of what the printer is doing before we see it at the end. All right, this is going to take about 12 hours. All right, this is what the 3D print looks like so far. Got the sort of base of the crown, the infill, the honeycomb infill, and some of the beginning of the support structure, the tree support structure. Here's the camera view inside the 3D printer, and we can see that it's just starting the top of the crown. You can also see that there's a change in color there. I actually ran out of filament of one color and had to substitute a different filament. The different color, that's gonna be a little bit annoying because I like my prints to look really nice, but kind of have to lean into the wabi-sabi part of it. But anyway, when this is done, it looks like we have about 2 hours left. When I pull it out, I will give you guys a close-up view of the finished product. Okay, this is the print. Pulled it out of the 3D printer. As I mentioned before, we ran out of one color sort of in the middle of the print. It takes about 500 grams to print, and a spool is about 1,000, so I think I didn't judge it quite enough. Anyway, the second layer is matching the same filament. It's just a different color, but kind of unfortunate. Anyway, we also have the main hole here that should match your standard bases for crowns, and we also have these two holes here that are essentially locating pins for when you put it on top of a particular type of brim form. All right, so the next step here would be to sand this, and I like to put a shellac coating on it, which is kind of a traditional coating for wood, only we're using it for a different purpose. Or actually same purpose is to prevent moisture from getting in, but it's a different material. Similar thing happened here on this one where I had to change color. Anyway, so that's going to be the next step, is to basically sand it, coat it, and then I'll probably do a pull and make a hat out of this. All right, now the next step is we're going to need a tipper. And if we look at this is a different brim form here. We made a tipper like this, which basically sits in here and pushes down on this concavity. All right, and we design it with these holes, matching holes to this, for the reason that some brim forms the crown sits on top, and some brim forms it's inverted. All right, here's one example. This is a brim form that's meant to sit on top. All right, and we would just pull the whole thing down over the top, and this would be the actual hat form. But there are going to be cases, and in this case this would sit like this, and then the tipper would be here, and we put a weight on top. Okay. Now there are other cases where the brim form is more curved upwards, so the brim actually looks like this when you see it. It's curved upwards, and the crown form actually sits down like this, and the brim form would sit up on a frame. So the hat actually looks something. The hat looks something like this when it's made. Okay. Now the trick is that for this to work, you need your tipper to be lined up exactly where the crown is, and this would line up and fit like that. And then this frame would actually be on a little bit of a stand, a frame stand that would keep it at the right height. All right, so that's the next step. We're gonna design and make this tipper in the next video. All right, that's it for this one, and we'll see you in the next video. Thank you for watching.